Okay, section 10 of the notes, it's the material and partial fractions. Partial fractions were covered in pre-calculus. They're certainly being reinforced here. Why are they being reinforced here? They're useful in some integration type problems. So what we're going to be given is a rational function. We're going to use partial fractions to decompose it. All right. So my claim is this: if you've paid attention to what we've talked about in the lectures and through the examples, the homework should become quite easy for you. And what are you doing? You're reinforcing what you learned by listening and paying attention. But the bottom line, you learn by listening and paying attention. You still have to try on your own, paper and pencil. All right. So this is my attempt at trying the homework. And some people just like to watch people do homework. But the intent, again, is at some point, you got to be able to do this independently of me. All right. It shouldn't take long to do homework once you master the material, though. All right. So I'm going to go through this, and I'll go through this at the whiteboard. So just give me 1 second and do another share. And let's see if this goes smoothly. Okay, we'll look at problem number 1. And number 1, it's, certainly I'll read it to you. It says, partial fraction decomposition for the rational function. And what's nice about this is the way it's written. It's written, the bottom's already factored for me. So what do I know? I know I can be decomposed into 2 fractions. Let me put that down for you. Let me see, my pen doesn't seem to be working at this point. Let me try it again. Get in. Okay, my pencil should be working. All right, let me unzip it then. Now there it goes. Equals, and what does it equal? Let me write it down. So there's going to be 2 different denominators. And so the first denominator I'm going to write down is the irreducible quadratic. I can't factor x squared plus 7 using real numbers. So x squared plus 7. And the other guy's a linear factor, which is nice and easy. So what I'm going to do, I don't know the tops of these things. So the numerator in the first guy is going to be ax plus b. And I got to use a different letter here. I'll use the letter c now. What I would do next is I'd multiply both sides by the LCD, which is fairly easy to do that. So the LCD, x squared plus 7 times x minus 5. So what would you get if you multiply both sides by the LCD? You get this. And on the right side, you get ax plus b times x minus 5 plus c times x squared plus 7. Okay, this is a critical first step. Now, granted, techniques differ. Some people look at this and say they're going to equate coefficients. Nothing wrong with that. I'm not going to say it's a bad technique. What I'm going to do is I'm going to pick a number that's easy for me to handle. And the number that, believe it or not, easy for me to handle is x equals 5. Right, now, if I do that, and again, certainly if you can do arithmetic, it would be good. So what are you going to get? And I plug it in the left side, and 5 squared is 25. So it's going to be minus 200 because I have to multiply by 8, minus 8. And then, minus 20, minus 68. That's the left side. Now, someone could say that's a lot of work to do. Not really. It's pretty simple to do that. Now, what's nice about x equals 5 is the right side becomes incredibly easy. And the reason for that, that first, ax plus b times x minus 5 becomes 0 now because x minus 5 is, if x is 5, 5 minus 5 is 0. So what are we left off with? C times 25 plus 7. Now, this is one unknown. It should be easy to solve. And what do you have there? 288, right? And what do you have here? Well, you get C, and 25 plus 7 is 32. So what do I want to do? I want to divide both sides by 32. And let's see if we can do that. And certainly, I'm going to certainly go one step at a time. Now, someone's going to use a calculator to do that. I don't mind using a calculator, but I think you should practice arithmetic. So 144, and let's see, 32 divided by 2 is 16. Right, divide by 2 again. Right, not bad to do. You get minus, let's see, 72. And then you get 8. That looks pretty easy. It looks like minus 9 now. I realize sometimes I could do that really quickly. Do it quickly. We're not asking you to go slow. All right, so I know what C is. So what I'm going to do up here, I'm going to write that down now. So I'm going to get my eraser out, and I know C is minus 9. So I'm going to erase this business up here, and I'll put down minus 9 instead. minus 9, right? So that wasn't bad. And someone says, well, what do you know there? C is minus 9. So I'm going to go up to the top here and I'll write that down. Let me get my eraser out. Okay, what are we going to do now? Certainly, I want to figure something else out. And someone says, what do you want to figure out now? Well, something else. And I'm going to try to figure out the b now. So I did x equals 5. Now I'm going to try x to be 0. And what would you get there if you did that? Again, when I did x is 5, I got this information over here. Now let's do x equals 0. What do you get? You get minus 68 equals, well, if x is 0, what would you get? Well, you get b, right, times minus 5. And then you get minus 9 times 7. And that's if x is 0. So it's pretty simple to do. 68, and that's going to be minus 5b, minus 63. Well, it really isn't bad. Add 63 to both sides, you get minus 5 equals minus 5b. Well, what do I know about b now? B is pretty simple. B is equal to 1. But just write that down for you. So 1, b is equal to 1. So I'm going to go up here, and I'm going to erase and put b as 1 down, right? So I know b is 1. Now, of course, I always say this a lot to you. Do we make mistakes? Of course we do. And that's why we give you keys. We want to make sure that whatever you're writing down, that you're comfortable with it. All right. Now, of course, I don't know what a is. All right. So I'm going to, what other number could I pick? And there's a variety of numbers you can pick, but I certainly want to stay easy. So I'm going to pick x to be 1. Because I think it's easy. All right. Now, someone says, could I pick a different number? Free to choose. Pick the number you like. And again, I want to remind you, we're plugging it in here. All right. So if you plug in 1, what do you get? You get minus 8, minus 4, minus 68 equals, I moved over a little bit. I said it's 1, so it's going to be a plus 1 minus 4. Again, I said x is 1, minus 9, and that would be 1 plus 7, right? Let's do arithmetic. And what do you get? Let's see, minus 12, minus 80. And you get minus 4a, minus 4, and then you get minus, well, 7 plus 1 is 8, and minus 9 times 8 is minus 72. All right, so I'll keep going. Minus 80, minus 4a. This would be minus 76. I'm going to add 76 to both sides, and you get minus 4 equals minus 4a. Whoops, I made a mistake there. Well, again, I really think that's easy. A is 1 now. So I'm going to go up here, plug it in, and that's a coefficient of x. So I'm just going to erase it because the a is 1, right? So it's got x, and I'll go over here. And let me just get my pen back out. This is x plus 1. This is x plus 1. This is what we want to come up with. All right. So the old question goes, did we get the right answer? And certainly we could check it. I'm not saying we can't. Like if I was on an exam, I would definitely check because I don't have the answer key. With an answer key over here, what am I looking at? I'm looking at the answer. Are we getting the same answer? Of course we are. All right, let's do this one here, number 2. And the answer will be on the next page. And let's go through it slowly. Right. So this looks actually easier than number 1. Multiply both sides by the LCD. And what do you get? Well, you get 5x minus 8 equals a times x minus 1 plus b times x minus 4. I would, I think I'd probably pick x to be 1 first. What does this give you? Well, 5 minus 8 is minus 3. If x is 1, the first term would disappear, and the second term would be minus 3b. What does this tell me? B is 1. Fairly simple. I'm going to pick another easy number. What number would I pick? Probably 4. What do you get over here? Well, 4 times 5 is 20. 20 minus 8 is 12. And I pick 4, right? So what do you get? 4 minus 1 is 3, so I get 3a. And 4 minus 4, that's the second term, would be 0, so I'm not going to write that down. And what's a? A is 4. So I know what a and b are, and they asked for that. I could box that, and because they did say determine a and b, well, I got a and b. If you want to know what the fraction is going to be, a is going to be 4, so 4 over x minus 4, plus b, and b is 1 over x minus 1. Let's go to the next page, and let's make sure we got 4, 1 now. All right. So a is 4 and b is 1. We did okay. All right. Let's do the next thing. And again, looking at it, they're being kind of generous over here. They're asking me to, figure this out. And I'm looking at it. And I'll make sure it's written down. Yeah, it looks pretty good. So multiply both sides by the LCD. Again, fairly simple. Minus 6x squared. These are confidence builder questions. Minus 30x, minus 15. And the LCD is x plus 1 times x plus 4 squared. So what do you get? 1 times x plus 4 squared. You would need to know basic algebra to do this. Minus b. Let's see what we get over there. We would get x plus 4 times x plus 1. And then we would get minus 3x plus 1. All right. So again, this is, I'm going to be able to get the b in this problem pretty quickly. And how would I do that? Well, there's many ways to do it. And certainly the way you choose to do it is up to you. All right. So, one way I could do it, I could probably equate coefficients here, but I still like that method of just plugging in numbers. So I'm going to pick x to be, I don't know, what's the easiest number? Probably minus 1. And what would that give us? That would be pretty simple. What do you get? You would get minus 6. I'm doing the left side first, plus 30. Let's see, minus 15. And again, I chose minus 1. I'm getting a little better with the arithmetic now. That would be 9. And then I get minus b. And let's see, I chose minus 1, right? So that would be, that's 0. I mean, that's not helping me out. What do you get over here? Well, you get minus 3 times 0. Well, gee whiz. That didn't help me too much, did it? All right, so what happens over there? Well, what do you get? Minus 630 minus 15. That's going to be minus 21. Yeah, 9. Did I make a mistake somewhere? Let's see if I made a mistake somewhere. Minus 6x minus 30x minus 15, x plus square minus b, x plus 4 minus 3. I chose minus 1. So, I see. I made a mistake in that last term. And I'm glad I looked at it. There's not a minus 3 there. That gets off. Is this correct statement? Well, if you look at the left side, and I want to make sure you understand what I mean by that, it's, minus 6 plus 30 minus 15. That's going to be 9, and 9 does equal 9. And this works out beautifully. Did it help me? No. So I'm going to just simply, pretend, let's erase it. Didn't help me at all. So then the question comes is, what other number could you pick? Well, I got to, minus 1 didn't work out. Minus 4 wouldn't work out, certainly. And the reason about this, that the b would still disappear. So I want to maintain the b. So I'm going to say, hey, let's pick x equals 0. All right, let's see if that gives it. What do you get? Minus 15. I'm picking 0, by the way. What do you get next? 16. Minus 4. I'm sorry, minus b. I'm sorry. I'm daydreaming. 4, because I picked 0, and 1. And what do you have here? Minus 3. Well, let's do this. This is minus 15. This is going to be 13 minus 4b. Well, let's see. I got to take 13 from both sides. That's going to be minus 28. What do you have here? Minus 4b. And b would be equal to 7. So I'm going to say, I found the b. I got the b. And the b is 7. Certainly agreeing with this over here. All right. So the other method they talk about is equated coefficients. I personally don't like the method, but a lot of students do. And what I mean by that, if you look at the problem over here, you're equating coefficients. And looking at it, I guess you could do it. What do you have to do? Expand it. What's the problem with expansion? It's work. So after you expand it out, I want to point out, looking at it, I'm going to put this over here. I'm going to just outline this for you. And what I do is I expand everything. So let me just emphasize what I'm talking about over here. So this side, there's not much I can do about that. It's going to get this side, I have to expand it. And if you do that, what's x plus 4 squared? It's x squared plus 8x plus 16. If you expand the other guy, well, that's x plus 1 times x plus 4. That's x squared plus 5x plus 4. That's pretty simple. And this guy expanded is minus 3x minus 3. I still got to go through the expansion, x squared. Someone says, where's the minus bx coming from? Right over here. What I'm doing is I'm putting all the x squareds together, and then I'm going to put the linear terms together. And what do I see over there? Well, I see 8x I do see that minus 3x. I see that. All right, maybe I'll put that in a different color. I'll do green. So I did this. And that's right here. And I'm going to do the other color now. I'm going to do now the color, same color, 8x minus 3x. And then I see the minus 5bx. Okay. And then the constant is what I'm getting. I'm getting 16. I'm seeing minus 3. And I'm seeing minus 4b. All right. So, the bottom line, I hope you realize that, we have this term here, and the coefficient is going to be 1 minus bx squared. Well, that looks good. And what's coefficient on x? Well, I'm looking at it, and I'm seeing this over here. That's going to be, let's see, 5, common to those things, and then I get 1 minus bx. Looks pretty good. Last one, I just get the constant. So now you equate things together. So it's a killer to do that. It's up to you, though. Some people like this method. So I have to say the minus 6 is the coefficient of the square term, so that's to be 1 minus b. This is super simple, though, and I want to point that out to you. If I look at that over there, what would b have to be? 7. Now, what would b have to be? 7. By the way, I want to make sure that I did everything good, and if b is 7, what would I get for the second term? Well, 1 minus 7 is minus 6, and 5 times minus 6 minus 30. That worked out beautifully. And do I get the last term? Well, if b is 7, 4 times 7 is 28. Right? 13 minus 28 is minus 15. And is that's what I wanted. That works out good too. So b is 7. All right. So b is 7 in every single case, by the way. Now, again, I actually prefer the first method. Here's the deal though. The first method doesn't always work. Sometimes you have to go back to equating coefficients. There's nothing wrong with that. All right. Make sure you know the both. This is tradition when you undetermined coefficients. It's really the traditional method of doing it. Let's go to the next page. And we're on number 3. I'm sorry, did we do 3? That was 3. We're on 4 now. So what's 4? Again, it's a repetition of the same stuff over and over again, but I need the repetition. I need to learn the material. So what do you get over here? Let's write this down. I'm going to multiply both sides by the LCD. So you get 5x plus 1 equals a times x squared plus 4. And then I would get, let's see, bx plus c times x minus 1. All right, what would I choose first? Probably I'd choose x equals 1 because it looks pretty easy to do that. And what would you get? Well, on the left side, you'd get 6. On the right side, you would get 5a. And then the second term there, that has a factor x minus 1, it would become 0. So at least I know what a is. And what's a? A is going to be 6/5. Right? I'm going to write that down for you. And I'll do that later. Let me do another number. And let me do, let's see, let's try, this was super simple, right? And the only other number I could find it might be really simple would be x equal 0. Let me put that down. What do you get? On the left side, you get 1. On the right side, you're going to get, well, let's see, a is 6/5, right? And then, 0 squared would be 0, and that's times 4, right? We'll do that later. Plus, I would get, because b times 0 is 0, so I'm not going to write that down, but you get c and times minus 1. And I got a little bit of work here to do, right? So I multiply both sides by 5, and I get 24 here, minus 5c. These numbers might be more nasty, but I think I can still do it. Take 24 from both sides, you would get minus 19 equals minus 5c. And now I know what c is. What's c? C is going to be 19/5. All right. So, if someone's looking at this and saying, what am I going to do now? Well, I guess I need to pick another number, right? So I picked 1, I picked 0. I guess I could pick, I don't know. Do I need another number? Yeah, I guess I do. Let's pick, I don't know, I'm going to pick 2. Again, a lot of people say is, could I pick a different number? Pick any number you like. Pick your phone number if you want. What do you get over here? Let's see, 5 times 2 is 10, so I get 11. And then a is 6/5, right? And then I said, I picked 2, right? So that's 4 plus 4 was 8. Now move this over a little bit. Plus, well, 2b, right? Because x is 2. What's c? 19/5. I will say one thing. If I make a mistake, it's going to pile on top of itself. And what's 2 minus 1 is 1. So what am I going to do? I guess I'd multiply both sides by 5 again, right? So 55. And let's see, that would be 6 times 8 now, right? Because I multiplied by 5. So it's 48. And if I multiply this next term by 5, I would get 10b plus 19. 55. Let's see, 48, 58, 57 plus 10b. Take 57 from both sides, I would get minus 2 equals 10b. And then I would divide both sides by 10, and I would get b equals minus 1/5. So I'm not saying it's the right answer. I'm just saying I think I could write down, did I make a mistake somewhere? Because it's saying a different answer over here. Let's see if I got this right. And I'm going to look at it. A is 6/5. And I got C is 19/5. And I got a wrong answer on B. And let's see where that went wrong. All right, let's see if I did that. It went wrong somewhere, right? So if I do 2, that's 2 times 5 is 10, 10 plus 1 is 11. That's good. And 2 squared is 4, 4 plus 4 is 8a. A is 6/5. I did okay there. I said x is 2, so it's 2b plus c. And I say c is 19/5. That's good. And then I multiply both sides by 5, 55. 6 times 8 is 48. 5 times 2b is 10b. And 5 times 19/5 is 19. I see it now. I'm going to have to erase. I made a mistake. I'm glad I have an opportunity to check myself. And yeah, the arithmetic is more difficult, right? I made a mistake. And I got to admit to it and correct it, just like you do too. So 48, 58, 68, 67, right? Whoops, I don't mean to do that. 67 plus 10b. Subtract 67 from both sides, and you're going to get minus 12 equals 10b. And if I divide both sides by 10, I get minus 6/5. And I'm getting that now, seeing that over there. Again, we did the partial fraction decomposition. We found what the A, the B, and the C in the problem, okay? So let's do this one over here. And again, it says, evaluate using long division first to write f of x as sum of polynomials and a proper rational function. So let's do that. And they're giving me a hint. I'm glad they did that because you might get confused otherwise. All right, there's many ways to do a problem though. I'm not going to say this is the only way to do it. But let's write this down. And I got to go through the details, right? What are the details going to be? Well, let's see. I got to do long division, right? So I got to do 3x minus 2 divided into x. Well, what times 3x would be x? That would be 1/3, right? Let's go through that. So 1/3, a little more difficult. You did math 100, but it's going to be x minus 2/3. And what I'm going to do now is subtract. So you get 2/3, right? So let's write this down. So what do you get? You get 1/3 plus 2/3 divided by 3x minus 2 dx. All right. Now, what do they want me to do? They want me to evaluate using long division first to write f of x as a sum of polynomials and a proper rational function. I've done that. All right. So let's see if we can maybe clean it up a little tiny bit. And again, we have an answer key. We can always look at that. And we get 1/3, which is super simple. Plus, this would be 2 multiplying top minus by 3. This would be 9x minus 6 dx. All right. And what I'm going to do is I'm going to split into 2 integration problems down. 1/3 dx, which is really easy to do, plus 2 over 9x minus 6 dx. All right. Now the first integration, super simple. What's going to be 1/3 of an x The second one, I'm going to use u substitution. What does u equal? 9x minus 6, and du would equal 9 dx. All right, so I'm going to write this down. I'll put a little star there, and again, I got to go back. I'm going to pull a 2 out. And what do you get over there? Well, the du would be 1/9. 1/9 of a du would be dx. What do you get bottom u? And I'm ready to go. What do you get? 1/3 x plus 2/9. This is the natural log, absolute value of u. And what's u? 9x minus 6 plus c. I could certainly check that by differentiating. A little tired though, and certainly I realize people get tired when they're doing homework, but I'm going to grab this answer here, and I'm going to copy it. I'm going to go back over here. I'm going to paste it. I want to see if I did a good job. And let's take a look. Get my red pen out. Got the 1/3 of an x. I see that. And I got 2/9 natural log. Ooh, there's a mistake somewhere. Someone says, ooh, there's a mistake. How could that have happened? I want to go through it with you. All right. And certainly someone's going to say, is there a mistake? There really isn't a mistake, but I still want to go through it with you. All right. So I'm going to write this down for you. And the ln, go through this with you. There's no mistake, by the way. I'm sorry. Go back to black ink. The natural log of the absolute value of 9x minus 6 is actually the same thing as the natural log of the absolute value 3 times 3x minus 2. And this could be written as the natural log of 3 plus the natural log of 3x minus 2. Basically what you learn in math. I guess that was 119. And what would I do over here? I would say that, 1/3 of an x plus 2/9 times ln 3 plus ln 3x minus 2 plus c. And someone's going to say, well, I'm starting to see it now. It's 1/3 of an x plus 2/9 ln 3x minus 2, absolute value, by the way. But I want to point out this over here, when you do 2/9 times this thing, it's a constant. I just integrate them into one constant. And you simply say, hey, that's another constant, c. And that's where that answer is coming from. All right, same answer. All right, same exact answer. All right. By the way, I can't say one is better than the other. Be aware of that. Sometimes some teachers might grade things wrong because they don't see what you've done. All right. Let's go to the next page. Make sure I've done that right. Yep, I did that one. Go to the next page. And now I'm going to do this one over here. It says evaluate the integral. And again, it's telling me to remember something. I don't think I need to be reminded that too often. The first thing I would do is I realized that it looks, I couldn't do it unless I did partial fractions on it. So I want to go through the partial fraction business first. And what's that going to be? 1 over. And I got to factor the bottom. I'm hoping it's going to be easy to do. And let's see. I'd say 3 and 6, right? And that equals a over x minus 3 plus b over x minus 6. Let me multiply both sides by the LCD, and you would get 1 equals a. This should be very easy, by the way. Please do not do things in your head. Write down as much work as you possibly can. Plus b, x minus 3. And I'm going to say x is 6. This looks really easy to do. What do you get? 1 equals 3b. So b is 1/3. Let's do x equals 3. You get 1 minus 3a. And what is that going to be? A would be minus 1/3. So I'm going to write that down for you. So I said a is minus 1/3 over x minus 3. And I said b was 1/3. Now, certainly, could mistakes happen? Of course they can happen. All right. I'll check it with my answer key. If I were on the exam, though, I'd be much more retentive. I would check to make sure that's true. And now I'm going to integrate it. All right, let's put this down. So this integration is going to be 2 separate integrations. The first one's going to be minus 1/3, 1 over x minus 3 dx. The other is going to be plus 1/3, the integration 1 over x minus 6 dx. And that's really easy to integrate. And I'll put this down and we'll check with the entry later. So minus 1/3 natural log of the absolute value x minus 3 plus 1/3, boy, natural log x minus 6 plus c. This is a fine answer. If that's your answer, you would get full credit. I want to go through some simplification though, and I think it's in your interest to do that. I'd probably factor out a 1/3. And I would write this as the natural log, absolute value of x minus 6, minus the natural log, x minus 3, plus c. And I'd probably pull those two logs together. 1/3 natural log, x minus 6 over x minus 3 plus c. All right, let's look at the king. I don't know what they put down. So let's see what they put down. No, they put this one down. Good deal, we got it. Let me point out, safe bet, really safe bet. Okay, let's go to the next one, number 7. And again, you should realize that this homework is relatively simple so far. I mean, they really haven't stressed me out too much. The worst thing I got is I got fractions. All right, so let's take a look. And I'm going to put down one step at a time. And I'm going to put the partial fraction down first, and 6x minus 1 over x squared. Now I got to factor that, right? Let's not be lazy. X and x. I'm going to say 3 and 2. I'll write this down. I'll write, let's see, a over x minus 2 plus b over x minus 3. Sorry about that. I can multiply both sides by the LCD. You get 6x minus 1 equals, let's see, a times x minus 3 plus b times x minus 2. Oh boy, what are you going to pick out? X equals 2. Fairly simple. That's 12 minus 1, which is 11. And then you get minus a. So I know what a is. A is minus 11. Let's go x equals 3 now. Again, because it's easy. What do you get? 18 minus 1 is 17. And let's see, what would you get over there? Well, 3 minus 2, well, that would be b, right? So what do you get? B is 17. All right, so I'm going to, write the integration down for you now with this in mind. And you're going to get, let's see, you're going to get a, which is minus 11. I'll put that to second term, by the way. And that's minus 11 over what? X minus 2. So dx. By the way, I don't like where the minus is, so I get my eraser out. Subtraction problem. And what's the b? The b is 17 over x minus 3. Well, let's go to town. What do you get? 17, right? Natural log, absolute value, x minus 3 minus 11, natural log, absolute value, x minus 2 plus c. The box in that. And again, it's a good answer. I want to point out the answer you're staring at right over here. Let's make sure we got the same answer though. I got that, I got that, and I got that. And all work is there for you if you want to take a look at that work. All right, so this one over here, I'm looking at it and I'm wondering what to do. Partial fractions. It's in the partial fraction section. So I'm going to do that. And let me write it down for you. And again, it may be a lot of work. I don't know. 13x squared plus 17x plus 2. And you get x minus 1 in the bottom, x plus 1 squared on top. So what do you get over here? Well, I get x minus 1. I get x plus 1. And I get x plus 1 squared. All right, so that's pretty good. Then what do you get over to A, B, C? What I'm going to do, multiply both sides by the LCD. It's work. And what do you get? A, x plus 1 squared, plus B, x minus 1, x plus 1. Again, we're assuming you have algebra skills to do this. This is not something you'd give a Math 100 student, for example. And we give it x minus 1. So what number are you going to pick? I'm going to pick 1 because I think it's easy for me. And if you want to pick a different number, go right ahead. So I'm going to pick x equals 1. And what does that give me? Well, make sure I'm getting this right. 13 plus 17. I think I can do that. That's 30 and 2, 32. I chose 1, right? So what'd you get? 1 plus 1 is 2. 2 squared is 4. So that's 4a. What's nice about picking 1 now, the following 2 terms disappear. So I now know what a is. What's a? A is 8. That's pretty simple. So I'm going to, basically get my eraser out. Erase this. Whoops. And put the 8 down. Now, granted, it might have been a mistake, but that's part of learning. You make mistakes. All right, what's another number you could pick? I guess I could pick 0. And what would that give you? 2. Now, remember, a is 8. So what would I get? 8. If I pick 0, what do I get for the second term? I would get minus b if I chose 0, right? That's not, it's easy. And what do you get over there? Minus c. That's 2 unknowns. I don't like that at all. But I need to rewrite that. What would that be? It took 8 from both sides. That would be minus 6. So I would get b plus c is equal to 6. Let me make sure that's true, by the way. So b plus c. Yep, looks good. Let's put another number down. It wasn't that helpful. At least I know that b and c add together to 6. I know that much. Let's pick another easy number. And I guess I could pick, let me pick minus 1. What would that give me? Let's see, minus 1 would give me 13 minus 17. That's minus 4. And minus 4 plus 2 is minus 2. Well, the a disappears because, minus 1 plus 1 is none. And the b disappears. That's good news. And what would the c be? It would be c times minus 2. So minus 2c. Well, that's nice. C is 1. So now I also know what b is, right? What is b? B is 5. I'm going to go up here and I'm going to erase. And let me see if I can do that. I think b is 5. Notice I say that word think. I always make mistakes. What I like about these is they're nice, easy numbers. And what's the c? The c is 1, right? Erase that, put a 1 there. Okay. So what I'm going to claim is, I really don't want to do a lot of writing, but I'm looking at this thing and I know there's 3 separate integration problems. This needs to be integrated, this needs to be integrated, and this needs to be integrated. This one's easy, but this might cause a challenge for me. So let me put this down for you. What do you get? 8 ln absolute value x minus 1 plus 5 ln. I'm doing the second term now, x plus 1. But I have to be honest with the third term, it's a little bit of a challenge. I'll put it down over here. So what do you get? Let's put this down. And by the way, if it's not a challenge for you, just do it. I really mean that. Don't think someone says it's a challenge for you. But I'm going to use U substitution. So what I want to do is I want to integrate this guy. And what would I do? I'd let u equal x plus 1 and du would equal dx. Well, it looks pretty easy. What do you get? You get 1 over u squared du, right? And that would be u to the minus 2 du. Well, what do I do with that? I have to add 1 to the exponent, right? So it's going to be u to the minus 1 over minus 1 or minus 1 over u plus c. So I think I'm ready to go. And let me see if I can do that now. So this equals, let's not forget what we have over here, 8 ln absolute value x minus 1 plus 5 ln absolute value x plus 1. And then what we have? We have minus 1 over, what was u? X plus 1 plus c. Again, do mistakes happen all the time? That's why we're going to look at the key. And I'm going to grab it. I'm going to grab this guy right over here. Pull him, copy him, edit, copy, delete, go back. I'm going to paste it. And I'm going to look at it, see how we did. And if I didn't do it right, you know what? I got to figure it out. So let's see, 8 ln x minus 1 looks pretty good. Then I got 5 ln x plus 1. Wow, another miracle. We got that one right too. All right, so far we're sound along. Let's go to number 9. I think that might be did I do something wrong there? No, I did it. It's all the work all over there. So let's do number 9. And number 9, geez, that looks really tough. I'll do long division. Let's see what happens. So I'll put this over here. And what do you get? I got to write this down. 4x squared plus 49 divided to x squared. That's going to be 1/4, isn't it? So you get 1/4 times 4x squared, which is x squared, plus 49 quarters. Got to subtract to get 49 quarters. Let's write that down. You can get integration, 1/4. And then you get this remainder. I didn't finish the division, did I? All right, a little painful. So I'm going to keep rewriting it. And I'm going to write down 1/4 minus 49 quarters. That's a 1 now, right? I'm going to factor a 4 out from the bottom, which sometimes really sounds crazy to do that. And what do you get? You get 4. What do you get there? You would get, you know what? I'm going to factor out a 49 instead. And what do you get? It's going to be tough. 4x squared over 49 plus 1 dx. Hope I didn't go too fast with that. Let me repeat this stuff. If I make a mistake, I'm going to know that when I look at the answer key. And that's what's great about having an answer key. I can look at the guy's work too. All right, let's take a look at that. It's great if you use it, by the way. If you don't use it, the answer key is worthless. So let's take a look at that. That looks really familiar, doesn't it? So I'm going to write this down so it even becomes more familiar to me. And that's going to be what? 2x over the root of 49. Now what am I going to do? I got 2 integrations and they look pretty simple. First one's going to be 1/4 dx. Next one's going to be minus 1/4 times this nightmare. Whoa, I think we can do it now. They wouldn't give me a problem they couldn't do, right? So let's take a look at that. The first guy's really simple to do. It's 1/4 of an x. The next guy, I want to be honest with you, looks familiar to me. So what I'm going to do is I'm going to say u equals 2x over root 49. So what's du? It's 2 over root 49 dx. I'll be real careful here. So root 49 over 2 du is equal to dx. Well, I'll start over here. I get 1. This would be, I'm sorry, I went too quick with that. Didn't look right. It's going to be u squared plus 1. And what's dx? Well, it's something. It's root 49 over 2. Put that in the outside, right? And I recognize it. Let's write this down. 1/4 x. This is going to be minus root 49 over 8. And this is going to be arctan, right? Arctan of u. What's u? 2x over root 49 plus c. Put a little box in that. And I hope I didn't make a mistake because I don't want to do that again. But let's go to the next page and I'm going to pull it off. See how we did. And sometimes I think I might have made a mistake somewhere. Oh, I know a mistake. And I'm just going to pull it off. I guess I'm daydreaming. Someone says, how do you know I made a mistake? It's not a mistake, by the way. It's just simply I didn't simplify something. And let me just make sure you know what I'm doing over here. I'm going to look at my answer. And let's see, copy, delete, go back a page. I'm going to paste this in. Let me paste it in for you. I'm going to go through it one step at a time with you, though. We got the x over 4. That's definitely right. Now, I wrote root 49 down. It's 7, though. And certainly I should have wrote 7 down. But this is fine. It's 7 over 8. Arctan 2x square root of 49 again is 7. We got the same answer. But again, I don't know why. Maybe I'm just daydreaming. Root 49 is 7. I guess I was daydreaming. Look at the next question. And that's number 10. Whoa. Evaluate the integral using appropriate method or combination of methods covered thus far in the text. I guess that they mean, because most people don't read, I guess what they mean is what I covered so far. And I'm going to look at that, and I bet this has something to do with the arctangent. So I'm going to try to write that so it looks sort of like that. I don't know if I can. Maybe I can. And let's see. So equals 8 root x. I'm going to write down something squared here plus 1. This is wishful thinking, maybe. But I got to be honest with you. Most of these problems are wishful thinking. We write problems that really do work out nicely. And what's this going to be? This would have to be x to the 3/2 here. So I'm going to give it a shot. I don't know what's going to happen. Let's see what happens. Let's believe in fairy tales. All right. So what do you get? I'm going to say u is equal x to the 3/2. Du would be 3/2. I have to reduce the exponent by 1, right? That's 1/2 dx. I think I'm seeing it. So 2/3 of a du is equal to square root of x dx. I think I'm ready. So I'm going to write this down. Again, we're doing this over here. I'm going to pull the 8 out. That's u squared plus 1. And then I got the root x dx, which I know is 2/3 of a du. And what's that going to give me? 16/3 arc tangent of u. What's u? Oh, x to the 3/2 plus c. Again, what's my recommendation? Look at the key and look at this and make sure they're identical. All right, if they're not identical, figure out why they're not identical. They should be identical. That's about it. So we covered that section. And again, make sure you understand what was presented to you. If you need additional support for whatever reason, please come by during office hours and I'll be more than happy to help you.